Hello, my name is Maria, and today I'll be talking about Kubernetes troubleshooting best practices. Just a little bit about me. I'm a developer advocate at KubeShop working on the Botkube project. Before that, I worked in developer relations in the cloud native space and in software engineering. My formal background is in industrial systems engineering, and you'll see some of that in today's presentation, some of that design thinking. And then finally, I have a dog named Malcolm X. As we all know, the Kubernetes cloud native space is very complex. There's a very high barrier to entry because you're required to balance a lot of information and complexity. You have to know about networking, you have to know about containers, you have to know about deployment, and many other things just to be able to get your Kubernetes cluster up and running, especially in a production environment. Additionally, most teams don't use Kubernetes by itself. They tend to use Kubernetes alongside other cloud native tools. And as you can see on the left, this is what the CNCF landscape looks like as of November 2023. And since then, there have been so many tools added. So it can be very challenging to manage both your Kubernetes clusters and these cloud native tools on top of them. In addition, in this new hybrid world that we're working in, it can be very challenging to troubleshoot problems in a timely manner. So a lot of teams are relying on tools like Slack or Teams or Mattermost or Discord to be able to get their emergencies or outages solved. However, you may have a case where you have teams in a distributed fashion. So might have one team in Los Angeles and one team in Tokyo, and it can be very difficult to share information and share context when it comes to working with Kubernetes. So this is the core of the presentation. So what is Kubernetes troubleshooting? In sum, I like to define it as monitoring plus action or reaction, and I'll be talking a little bit about that concept of reaction and action. But formally, it's the process of identifying and resolving issues in a Kubernetes cluster. So why is Kubernetes troubleshooting important? Like any kind of troubleshooting, it's the core of incident management and monitoring. So what do you do with the information that you receive? And Kubernetes troubleshooting can be helpful for resource use and cost optimization. So the less downtime, the better. It can also increase the efficiency of a team, increase your reliability, and because you're spending less time on troubleshooting, you can also spend more time coding and creating more innovative solutions. So one example of a Kubernetes troubleshooting scenario is an ohm killed error. This is one of the most common kube control errors that you could receive. And this basically just means that when there is not enough memory, Kubernetes will kill the pod and go through a cycling process until the memory is resolved. So when you receive an ohm killed error, here are the 5 steps that you would typically use. So first, you would identify the container or pod that was terminated. Second, you would check the memory usage of the container or pod. Third, you would look for any errors inside the container or pod logs. Then you would update the container or pod image, then increase the memory limit for the container or pod. So this is a 5-step process, and you might think, oh, okay, 5 steps is not that bad. However, if you multiply it by multiple clusters, and then also add in the fact of if this scenario happens outside of working hours, this 5-step process can take minutes, hours, or even days in an unorganized team that doesn't have a structured troubleshooting process. So this is what that workflow could look like inside of an engineering team. So a developer might receive the information and report the outage inside of an incident management tool that a team is using. Then they would notify the DevOps team. and then the DevOps team would assess the Kubernetes environment, and then you confirm that information with Kubernetes, and you'd loop back in with the SRE team that would kickstart that troubleshooting process. And then you would begin troubleshooting, update the incident status through the incident management tool, and then notify the rest of the team about that the incident has been resolved. So that's a lot of steps and a lot of people involved in the process. So every team has different challenges when it comes to Kubernetes management and monitoring and troubleshooting. So from a DevOps team's perspective, they're frequently understaffed and overworked. And because they sit in the middle of operations and development, they frequently have to context switch between different teams, different contexts, and different tools. So this can be a very overwhelming and overstimulating environment for a DevOps team. And from the developer's perspective, because we're leaning more into this cloud native landscape, there's a lot of expectations that are placed on developers when in reality, they shouldn't have to learn Kubernetes and become very versed in Kubernetes and cloud native tooling just to be able to check on their app health and keep their apps up and running. And then from the operations team's perspective, maintaining reliability in this cloud native landscape is a top priority because it can mean the difference for security risks and overall cost efficiency and operation efficiency. So we talked a little bit about the complexities of Kubernetes from the team perspective, what it's like working with Kubernetes in general. But a lot of companies are also using Kubernetes at scale. So some companies will have 20 plus clusters in their workflow and having to manage all the information that goes around it and all the support that's required for so many clusters. And these large scale environments can be very difficult to pinpoint when there's issues because there's not a lot of visibility between the clusters and not everyone has the same amount of access. So this can be challenging when you're working in a team environment. Additionally, at that scale, you're not using Kubernetes bare metal. So you also have different tooling, maybe you have different dashboards, different monitoring tools, different deployment mechanisms for all of your clusters. And then finally, it can just be very challenging to keep track of all the history and all the events that go on in the multiple clusters. So we talked about the problems, and now we're going to get into the solutions. So here are our Kubernetes troubleshooting best practices. Number one, we're going to want to centralize our monitoring and observability. Number two, we're going to highlight incident response and collaboration. Third, we're going to learn how to establish a feedback loop. Fourth, we're going to streamline our command execution. And fifth, we're going to automate our observability and delivery processes. So what is Botkube and how does it help teams follow troubleshooting best practices? Botkube is a collaborative Kubernetes troubleshooting and monitoring tool. And what this means is that you're able to monitor and troubleshoot your events in the same platform. So Botkube acts as an agent in between your communication platform and your cluster. So it is a bidirectional communication. So instead of, let's say, hooking up a webhook to Slack or Teams to just receive alerts, you're able to actually take action on them. You're able to filter those alerts. You're able to label them, modify them based on your team's needs. So it takes the idea of monitoring to the next level and really starts to think about what automation and real-time monitoring looks like in a Kubernetes environment. So here are some of the integrations. So from the communication platform side, it integrates with Microsoft Teams, Discord, Slack, and Mattermost. And one of the many tools that it integrates with, CNCF tools that it integrates with, is Helm, Argo, Flux. It also works with ChatGPT, Prometheus, and GitHub. So our first best practice is about empowering observability. So what this means is monitoring is more than just receiving alerts and data. You want to be able to have some sort of context around the information that you receive. So you want to be able to have real-time updates on your environment. So by using a tool like Botkube, it acts as a watchdog, so you can be informed of changes and be able to be more proactive when it comes to your incident response. And you're able to create channels for different types of alerts. So, for example, your development team doesn't need to see the same amount of alerts as, let's say, your platform engineering team. And when it comes to incident response, you can create individual channels to solve your rare errors or isolated incidents. So, from a contracting or customer perspective, this is good for isolation and focus. Alongside talking about incident response, you're able to resolve your issues directly from your communication platform. So instead of having to navigate, so you receive instead of receiving an event, let's say in a dashboard that may be connected to Slack, you can and then going to your terminal and then going through all the steps of resolving your incident. With a tool like Botkube, you're able to directly resolve your issue from Slack or Teams or Mattermost, which allows you to save time and prevent a lot of this context switching. And because it's in a shared communication platform, your whole team is able to see the process. So it cuts down on that reporting piece. And you don't just get an alert, you're able to see like the resource description of what actually happened. And going alongside of talking about collaboration, because you have an influx of information, you're able to establish a feedback loop and be able to get insights about your application behavior. So this is great when it comes to not only analyzing cluster performance, but it can also be good for team performance. So with the audit logs that Botkube has, you're able to see who and what happens inside of your cluster from which channel, which is great for, for example, monitoring who has permissions for what. So if you have a junior SRE on your team and you notice that you're having some more of the same errors popping up, you can find the root cause of that error just by looking to your audit logs. And with this amount of information, you're able to continuously improve. So going back to the concept of action versus reaction. So when you have that additional information of your history of all of your incidences that occur, you're able to be more proactive and be able to see the telltale signs of when incidences are about to occur by having all this information stored. And the fourth one is, so we talked a lot about the information side, but on the action side, you're able to utilize different CNCF tools inside of your communication platform. So this really opens up the doors to talking about that developer self-service. So from the developer's perspective, you don't have to be a Kubernetes expert. You can use a drag and drop format to be able to build out your Kubernetes commands. And then this also works with different tools in the CNCF landscape that may not have been accessible for non-Kubernetes experts. So you can really speed up your command execution process by not having to rely on your Kubernetes experts on your team to get things done. And taking that one step further, with Botkube, you're able to not only streamline your command execution, you're also able to have automation set up in place. So with automations, you're able to reduce the manual steps that occur in your troubleshooting process. So if you notice that whenever there's a resource that's created, you run the same kube control describe over and over again. By having an automation built in place, you're able to remove that first step out of your troubleshooting process. So it can really help speed up your monitoring and troubleshooting experience and make you a more resilient team. So this is what the previous workflow looked like, but now with Botkube. So with Botkube, you're able to take a 5-step process and turn it into 2 steps. So with Botkube, the first 3 steps can be managed through an automation. So Botkube can identify the container or pod that was terminated and help you check the memory usage by having all that information in the log, and then give you the errors up front. So all you have to do is react to the information that you got and manually update your container or pod image and then increase your memory limit. And this is what this workflow would look like with Botkube. So you get all that information. So you get your information or event coming from Kubernetes. It goes to Botkube. It notifies the entire team on Slack or Microsoft Teams or Mattermost or Discord. Then, depending on who has access to read-write commands, they're able to take action on that event through Botkube, and then Botkube will execute those commands to Kubernetes. So it cuts out a lot of the middle steps that occurred before using this type of tool. And when we talk about improvements, we want to be able to quantify them. So the main ways that Botkube can really improve your troubleshooting experiences, it can really help reduce the mean time to recovery by, if you look back at that chart, by reducing a lot of the communication jams that occur. It can increase your operational efficiency by speeding up your monitoring process and by removing the steps of information transfer by putting everything in one shared communication platform tool. It can also help reduce your team burnout. So if you look back and think about that that DevOps team's perspective, by reducing the amount of context switching and pressure on the DevOps team to be the quote unquote Kubernetes expert, it can really help reduce team burnout. And then with those 3, it will help reduce the number of outages by allowing you to be more proactive when it comes to incidences. So you can prevent, small incidences from becoming larger outages. So one example of Botkube IRL, so we have a customer that's a shipping company, and they use Botkube to manage their 2 clusters. One is production and staging. And they use Botkube to help automate some parts of their troubleshooting process. And like a lot of teams, they have like one Kubernetes expert and then the rest of their development team. And what they use is, so Botkube's RBAC is tied to Kubernetes RBAC and Slack. So each channel ties in like a user. So in a private channel, you can have the access to the limited amount of information or the ability to run commands against Kubernetes. So it builds in an RBAC system for their team. So it can help with the reliability and security when it comes to managing their Kubernetes clusters. So in conclusion, it's very important to not be reactive when it comes to Kubernetes troubleshooting. It's good to have a strategic approach based on your team's history and the resources available to your team. And by centralizing and automating a lot of the steps in your troubleshooting process, you can become a more resilient and reliable team. And using a tool like Botkube can package all of that efficiency and reliability in one piece for your Kubernetes clusters. So now I will be getting into the demo. All right, thank you so much for watching this presentation about Kubernetes troubleshooting. You can scan the barcode here to go to the Botkube website and get started and try Botkube out. You can always contact me in the Botkube Slack, which you can find on the Botkube website. Thank you so much for your time.